comprises all explosives. In this class, we find practice ammunition, plastic, military and technical explosives, and ammunition used in hunting and sports. Most explosives are not to be transported by air because they are too dangerous. Here is a parcel containing 5 kilograms of TNT and its effect. But even small amounts are enough to cause a lot of damage. For this reason, explosives from only 2 subclasses may be transported by air. Explosives in subclass 1.3 with the compatibility letters C and G, and explosives in subclass 1.4. What are their properties? 1.3 C and G are flammable. There is little risk of splinters, fragments and broken pieces. Subclass 1.4 contains substances and objects which are not significantly dangerous. For example here, these flares and smoke signals. Compatibility group S is of particular interest. This group includes safety ammunition, for example, sub-caliber ammunition for weapons used in hunting and sports. Summarizing once again the properties of explosives which may be transported by air, they have a fire risk and they have a low risk of explosion and splinters. Let's have a look at hazard class 2, the gases. A distinction is made between compressed, liquefied or frozen gases and those which are dissolved under pressure. The pressure represents the overall risk. 2 tests illustrate this fact. This container is filled with 300 grams of a non-flammable gas, carbon dioxide. If the container or seal is damaged, the effect is similar to a gunshot in the hold of an aircraft. Spray cans are also pressurized containers and can burst if they are exposed to high temperatures or a drop in air pressure. That's why pressurized containers must never be heated or damaged. The various Class 2 labels, apart from showing the general pressure risk, also indicate additional properties. This green label stands for non-flammable, compressed as well as for frozen liquefied gases. These gases, for example liquid nitrogen, are unbelievably cold, minus 192 degrees Celsius. A rose dipped in liquid nitrogen freezes within seconds and shatters like glass. The following experiment shows another property. These gases are heavier than air. They displace the oxygen and make breathing impossible. The red label indicates compressed gases, which are also flammable. These pressurized containers contain flammable gases. Here is a demonstration with hairspray. Furthermore, an explosive effect is achieved by a correct mixture of gases with air. This balloon is filled with a mixture of gas and oxygen. You can imagine the effect in the hold of an aircraft. We now come to the compressed gases, which are also poisonous. Poisonous gases spread very quickly. If inhaled, they can cause serious damage or even death. They are, therefore, not allowed to be transported on passenger aircraft. Let's summarize the facts. Class 2 gases are transported in pressurized containers. These containers can burst. Depending on their other properties, these gases can produce low temperatures, displace air, be flammable or poisonous. Flammable liquids come under Class 3. This class comprises liquids which give off flammable vapors. For example, varnish, solvents, lighter fuel, kerosene, and adhesives. These substances have varying flash points. This is defined as the lowest temperature at which the vapor coming from a liquid can be ignited in air. These include all liquids with a flash point of 60.5 degrees Celsius or less in a closed container, or 65.6 degrees Celsius in an open container. Let's look at a few examples. Isopropanol, an alcohol, gives off enough flammable vapor at 10 degrees Celsius. Room temperature and a warm spatula are enough to ignite carbon disulfide. Kerosene has a completely different effect. It does not burn at room temperature. It must be heated to over 40 degrees Celsius before it emits enough flammable gas. Summarizing, the dangerous goods from Class 3 are flammable at temperatures from 60.5 or 65.6 degrees Celsius or below. Hazard Class 4 has 3 subclasses. Subclass 4.1 includes flammable solids. For example, here, nitrocellulose, better known as gun cotton. What are its properties? It burns very quickly. These substances can ignite as a result of frictional warmth or heat. Substances with this label belong to subclass 4.2. These substances are difficult to film in the studio as they combust spontaneously in air. They include, for example, phosphorus. Subclass 4.3 includes those solids which form flammable gases with water. Let's observe carbide. It does not burn when dry. However, as soon as water is added, flammable gases evolve. Let's summarize the properties from Class 4. The solids are flammable, ignite spontaneously, form flammable gases with water. Hazard Class 5 has two subclasses: oxidizers, organic peroxides. Both can promote or start fire because they emit oxygen. With the aid of a welding nozzle, it can be seen that when oxygen is added to the flame, it turns blue. The flame gets hotter and combustion is intensified. The same effect can be observed with the oxidizers in subclass 5.1. For example, potassium permanganate. Here also the flame turns blue and combustion is accelerated. Organic peroxides also stimulate combustion. As here with benzoyl peroxide, they combust explosively. There are also organic peroxides which react spontaneously with other chemicals, for example, glycerine, and combust on their own. Let's repeat. Both subclasses provoke fire, react dangerously with other substances, and are sensitive to heat and friction. The dangerous goods in Class 6 are divided into two subclasses: poisons and infectious substances. The label for subclass 6.1 indicates danger. Very poisonous substances carry this label. Less poisonous substances have this label. Here are some examples of the commercial products in this subclass. These substances are not only poisonous when swallowed, but also when inhaled or in contact with skin. Great caution is therefore required when dealing with damaged parcels. Infectious substances belong to subclass 6.2. These are microorganisms, or, in this case, bacterial cultures for research. Infection is possible on contact. Let's summarize. Substances in Class 6 are poisonous or pathogenic. Consequences: infection, disease, death. Now we come to radioactive substances in Class 7. These substances are used in medicine, industry, and in nuclear engineering to obtain energy. Our senses cannot detect the radioactivity emitted by these substances, but by using technical aids, like for example this Geiger-Müller counter, it is possible to detect the radiation, the level being given as an audible signal. Radioactivity arises from the breakdown of atoms. They emit such high energy that they can penetrate this block of iron. We must therefore protect ourselves. But how? The best protection is to keep your distance. You can hear that the radiation decreases. Time is another protective factor. The shorter the time spent in the radioactive area, the less the amount of radioactivity absorbed by the body. A part of the radioactivity can be shielded, and in practice, this is achieved by using special packaging. The International Atomic Energy Agency has laid down maximum limits for cargo with radioactive contents. These limits also provide protection and apply to 3 categories of parcels. Parcels with this label emit the least amount of radioactivity, and parcels with this label emit the most. Let's summarize. Radiation damages the environment. You can protect yourself by keeping your distance, limiting the time spent in the radioactive area, shielding the radioactivity, and observing maximum limits. Corrosive substances, such as acids and alkalis, belong to hazard class 8. Here we are adding hydrochloric acid to aluminium, a light metal which is also used in building aircraft. As you can see, gases are evolved immediately and the aluminium is broken down. Concentrated alkaline solutions have a similarly vigorous reaction. What are the properties of acids and alkaline solutions? They produce heat and gases, destroy living tissue and other material. All those dangerous goods with properties which have not already been discussed belong to Class 9. Vehicles, magnetic substances, and dry ice. Dry ice is very cold, minus 70 degrees Celsius. However, as it only becomes gaseous when warmed and does not produce any moisture, it is the ideal cooling agent for transportation. The gas formed, however, does have a disadvantage. It is heavier than air and displaces oxygen. That is why rooms used to store dry ice, for example here in the hold of an aircraft, must be aired before entering. Let's look at another example from Class 9, a magnet. Magnets do not place people at risk directly, but they form magnetic fields which may influence compasses, videotapes, data storage media, and measuring equipment. Let's summarize. Dry ice is very cold. It displaces air. Magnets influence instruments and destroy information on data storage media. You are now familiar with the most important properties of dangerous goods. Please observe the ICAO and IATA regulations and thus ensure that these